Welcome to the Faster Podcast by FLO Cycling, the podcast where we talk about anything and everything that makes you faster on your bike. This is episode 23, and today we have Tom Anhalt from Blather, Bout Bikes joining us on the show. Tom is a mechanical engineer and avid cyclist who has a passion for studying rolling resistance and aerodynamics. Tom shares his studies on his popular blog, Blather Bout Bikes, and uses the data from his own studies to improve his cycling. Listen to part 1 of this episode to learn what one of the industry's most respected engineers has to teach you about rolling resistance. All right, Mr. Tom Anhalt, welcome to the show. How are you doing today?
I'm doing good. How are you guys?
We're doing great.
Good, thanks.
Cool. And you're still in California, right?
Yes, Southern California. Yep.
Southern California. Are you buried in rain like we are right now?
No, it's a bright sunny day today. But yesterday, or the last week's been pretty rainy, which is good.
Okay, cool.
To a point.
Good. So you have to stay off the mountain bike trails. Well, I guess you've been off the mountain bike trails for a little bit because of that knee injury, right?
Yeah, I've been off the bike for a while. I broke my leg in a mountain biking accident end of October. So,
okay.
Yeah.
And the recovery's coming pretty well?
Coming along really good. This week I was able to put 100% of my body weight on that leg, and I actually took a walk around the block earlier.
Nice.
It's got to be huge or feel great, hey?
Yeah.
Awesome. All right. Well, we wanted to have you on the show today because you are kind of the unspoken engineering expert of cycling and triathlon, and so many people use your information, your knowledge. You have written for a lot of publications just because you're so intimately involved with the sport, and you are a super smart guy who knows a lot about the industry and the gear and the equipment that goes into it. And you've done a lot with rolling resistance and some other things with aerodynamics, and we really wanted to talk to you about your specifically about that today, just to get all the information we can about rolling resistance and aerodynamics for our listeners to help them get a little faster. So let's get right into the questions.
I'll do my best.
All right. Yeah. Well, I think you're going to be fine. So we'll just start with the basics of rolling resistance. And for those who don't know, can you just start by explaining what rolling resistance is and how it slows you down?
Sure. In the simplest sense, it's the name of it describes. Rolling resistance is the resistance of a wheeled vehicle to rolling. And as you start moving forward, there's a force that pushes back. So the real difficult thing to kind of wrap your head around is what causes that. And in the simplest sense, what causes that really is the material properties of the tire, assuming this is a vehicle with a pneumatic tire on it. And you guys have done a lot of work with contact patches and the pressures and things like that. So I know you guys understand that in the, as you put a load on a wheel, that there is the force causes the tire to deform where it touches the road surface. And as you're rolling, and in a static sense, that's really easy. What's the area that's pushing back is equivalent to the pressure that's inside the tire times the area is the force is equal, all that stuff. Well, what happens when that tire is actually rotating? So what happens is that the front half of that contact patch is being compressed. At the same time, the trailing half of that contact patch is actually pressing back on the road. If you think about it that way, the pressure is being relieved in that half.
Yep.
Well, what happens because of the material bending, there are losses, internal losses in the tire material, and so that for the force that's being pushed to compress the contact patch in the leading half. If you sum it up over that surface area, it's going to be actually higher than the force that's pushing back down on the trailing half. And because of those unequal forces in the contact patch, in the two halves of it, what you end up with is a resultant a backwards torque on the wheel itself. This is kind of hard to describe without pictures,
Yeah,
Being a
it's
mechanical
even hard to
engineer,
describe
it's
with
like,
pictures.
I know. But being a mechanical engineer, it's like, it's like I'm trying to like use my hands while I'm talking to someone verbally, and it's like this isn't working. I need a picture. But yeah, I mean, I think you guys might have some info on that. I know I did some stuff a long time ago. I wrote something for Slow Twitch that had a pretty much a diagram of what I was meaning by that. So that's in the simplest sense. That's assuming that the tire itself is the complete source of that rolling resistance. There's other things that come into play though when you start thinking of a bicycle as a suspended vehicle, if you will.
Yep.
And so we'll probably get into more of that later. So a lot of those things get lumped into what is called rolling resistance, whereas you have the pure rolling resistance of the tire versus, I like to call it, the resistance to forward motion.
Yep.
So anyway,
cool.
I hope that wasn't too complicated.
No, that's a very good description of it. It is very tough to explain without pictures. Even when you have pictures, we've tried on our blog to simplify it as much as possible, and it's like, okay, how do I dumb this down as much as possible? So, so knowing what rolling resistance is, how much of an effect can it have on our speed? And let's take a really bad setup of tubes and tires and pressure, and then have an optimal setup. What kind of wattage can we look at losing if we have a bad setup?
Well, yeah. So there's a very wide range of options for tires, and a lot of it has to do with the construction. A very heavy, thick casing and tread, something that's designed to not puncture, even in case of the sharpest scalpel known to man. Those kind of things will tend to dissipate a lot of energy in just bending the tire itself through the contact patch. Whereas a very high-end race type, the other opposite end of that would be like a super thin track tubular, right?
Yep.
Is going to be almost flyweight. It's like you almost think if you held it up to the light, you could see through it, kind of thing. It's going to be a dramatically different rolling resistance. I mean, off the top of my head, I know that some of the slowest, if you will, tires I've tested, you could be giving up easily 20 to 25 watts compared to a decently fast tire. Nothing that's like not a track tubular, but something that would, you wouldn't have a problem with riding outside in most normal conditions. But it can be a pretty, it's a lot more than most people think. Let's put it that way.
Is that per tire or total system? The 20 to 25 watts.
I'm sorry, could you repeat that?
The 20 to 25 watts, is that per tire?
Would be.
Or for both tires?
Yeah.
Wow.
Okay. I think Chris is breaking up, so.
Oh, sorry.
That's all right.
Can you hear me now?
Yeah, we got you.
Okay, much better. Yeah. So when you said the 20 to 25 watts, was that per tire or for the combined two tires?
That could be for a pair. I mean, I'm looking. I have. You guys have known about this. I have a spreadsheet that has all the different tires I've tested, and if I look at the worst to the best on that list, so the worst being a old Specialized all condition armadillo reflective sidewall 25C, that was dissipating 71 watts for a pair of tires at 40 kilometers per hour. Now, if I compare that to a Vittoria Corsa Speed 23C, it's 23 watts. So I was actually being generous. That's a 50 watt difference to go the same speed
per tire.
Go 40. No, that's for the pair.
That's the pair. Okay.
Yeah. So that's like 25 watts a tire. Yeah.
Wow. That's unreal.
Yeah.
Right. And now that's a pretty extreme example. I mean, that one's there's a lot of what people would call training tires on the list. Continental Gator Skins, just something like a Specialized Turbo Pro, things like that. Those are in like the mid 40s range for a pair of tires at 40 kilometers an hour. So
Cool.
even that's 20 watts over that Vittoria Corsa speed.
Awesome.
So,
Wow.
So those who don't know,
turbo
Tom,
cotton.
Yeah. Those who don't know, Tom runs a website or a blog, I guess, called Blather about bikes. And he has, I would say, probably one of the best resources online for rolling resistance numbers. Tom does a specific test. And I'd like you, Tom, to explain how you test rolling resistance to the audience so they understand what it is you do and how meticulous it is to actually get one of these numbers.
We've done it many times.
Yeah, I know. You guys, we've talked about this before. It's what's interesting is how I got kind of into doing this. And there was a guy, Al Morrison, who I was familiar with many years ago, who started doing, looking at tires, and this is all in the sense of for time trials or for triathlons, and he was like going, how can we figure out on our own, which tires are faster than others? And so he started. He lived in Northern California, so he had a little more weather than I have here in Southern California. So he periodically would do like recovery rides in a shed. And he had a set of rollers in a fork stand that he would do it on, and he started doing these things, or started just trying them out. And he had a power meter on his bike, and so he said, okay, to go the same speed with this weight, what does it take? Well, that got me interested because I started wondering about, well, how does that translate to what's in reality on the road? And
Right.
So there was a point in time where Al actually tested a pair of tires on his rollers and then sent them to me in the mail, shipped them to me, and then I tested them outside on the road using some of the I actually did that initial test using what's called a regression method, where you find a flat course and you go in opposite two directions and out and back. So you'll go one direction, try to hold a constant speed, then you go the opposite direction, hold the same speed. And you average those, and you just get a series of points at different speeds. And from that, you can get not only the air resistance, the coefficient of drag, but you can also get the rolling resistance of whatever you're testing. Yep. It takes a lot of time to do stuff like that. So anyway,
yes, does.
That's why the appeal of being able to do these things on rollers was high. So what we found was that it matched pretty well, and there's other people who've done the same thing. So I was interested in finding out for myself what tires are faster, because I was doing a lot of time trial racing at the time, and I wanted to know, okay, I didn't want to be giving up watts where I didn't need to. If I could just buy a different tire, why not? So I started doing my own testing. I got I got a set of rollers from a friend actually, and got set up and started doing it myself. And one thing led to another. I started. My intent was I didn't want to be the guy who everyone was sending tires to test, because that would just take.
Sorry, we sent you a big box.
and so at that point, I just started writing some of this stuff down on the blog that I have, and I'd really I put out a whole how-to, because I didn't want to be the guy who was testing it. Here, you guys can do this too. Everyone can do this. Even if it's just in a relative sense, of I've got these things, and if I try them all out together, you can pretty much tell, even without a power meter, which ones are fast and which ones are slow.
Right.
And at the same time, I also looked at some of the when I started looking at the kind of the theory of, okay, you've got this rollers with a curved contact patch, and how does that relate to something that is on the flat surface like a road? And so I looked at a couple different sources, a couple different references, and in the old cycling science, or I'm trying to remember the name of the book now. Anyway, I think it was Cycling Science. There is a set of equations, and so I actually made like a little white paper that I put up on the blog as well. It's like, okay, here's the math. This is why you can do this. and it kind of went from there. In the end, I did end up being kind of the guy testing all the tires.
Yeah.
just from a consistency standpoint. I haven't actually done a lot of road tires in the last. In fact, the blog itself, I have to apologize. I think it's been over a year since I've put a new entry on it.
Yep.
But yeah, it's kind of just been organic in how it's been used, but it was pretty amazing the value that was found in it by a lot of people.
Yeah.
So,
No, it's huge.
Yeah,
For sure. How many
I
rolling
think it's
resistance?
I think it's interesting to say that what Tom's test is we actually have done quite a bit of work in rolling resistance as well. We've talked extensively with Tom. There's a specific protocol that he has that he takes out and uses rollers. And one of the big questions is how do you transfer that out to the road? We've started doing that in a number of series. I don't know if people remember, but we had a computer that we basically built to mount to the front of the bike back in 2015. It collected a bunch of data, which helped us design our wheel line. And then after that, we started looking at more detailed stuff and trying to understand rolling resistance. And there's a famous guy in the cycling industry called Robert Chung who has done a lot of great stuff for determining CDA, so your drag coefficient while riding outside. It's got a specific protocol that makes it a lot easier. And there's a small section in that protocol that discusses how to simultaneously collect CRR and CDA. And Tom stated that it's time consuming. I've done a number of those tests on these hill tests, and it can take 2 hours, per test after to process your numbers. So it is very time consuming. There's actually some really cool advancements coming out right now from sensor technology that we've actually acquired one of these sensors and are doing some really cool stuff. So we'll have some of that out. So hopefully a lot of the tests that Tom has done over the years have kind of got us in the right direction. I know, Tom, you've worked extensively with some of these people to sort of validate some of the stuff that they're doing. And I think it's, it'll help definitely. I mean, if you had to say how many rolling resistance tests you've done, how many do you think you've done?
Well, I know at a minimum, if I look at the spreadsheet, there's just over 90 on the list, and I know I've done probably at least twice that.
Yeah, that's exactly why these guys are contacting you to figure out how to do this. So yeah, it's
just with other things, it's really interesting, and the main things that I've learned on the testing that you can get really good consistent results if you know exactly what the load is. In other words, you measure it at that time. You have a really good measurement of the speed, what you call the ground speed. So like one of the things that I do in my test is I actually attach a magnet to the roller and sense the speed off of the roller, because that's consistent. It's not changing from tire to tire, pressure to pressure. You don't have to worry about tire rollout when you do that.
Yep.
And then the last one that it kind of took me a while to figure out how important it was, and it turns out it's more than you would think, is temperature. If you know what the ambient temperature is, the tire itself warms up, but it tends to be a function of the ambient temperature. And so I did early on. I had done a bunch with a single tire over different. Luckily, it was a time of year that the temperature changed dramatically over the course of a couple of weeks. Yep. And I'm doing this testing in my garage. It's unheated. And so I didn't have the luxury of having a consistent heated, temperature controlled test area. Yep. And so I actually took a single tire. I ended up, it's still kind of my control tire. I have an old Conti GP4000S that is my kind of the golden tire. Yep. That if something doesn't look right, I just throw that one on and see, okay, what's going on, and I can usually figure out what has changed, or what am I not accounting for, yep. or no, that is a real answer, that kind of thing.
Right.
And so I did a series of tests using that and kind of came up with a temperature compensation. The colder it is, the higher the rolling resistance typically.
Okay.
And just those three things, the speed, load, and temperature, you can get very consistent results. And Yeah, it's I know I'm probably making it sound overly simple, but that's
He really is. It's not that easy. It's really not.
It's the gist of it. So
Yeah. Okay, so you had mentioned that for the most part, your rolling resistance values from the smooth rollers to a pavement surface checked out. They were pretty similar from tire to tire. But there is a term that has been coined lately, and I think that you helped Josh Portner from Silka, used to be Zip, coin the term impedance.
right.
Can you explain to us what that is, how you discovered it,
Sure.
and how it slows you down?
Sure. But before we get to that, I want to explain that when I said that they match the rollers versus the outside rolling resistance, it matches with a kind of a factor on top of it.
Okay.
Obviously, the rollers that I'm using some Kreitler 4-inch diameter rollers, or 4.5-inch diameter. I can't remember. I haven't measured them in a long time.
Yep.
They're smooth, and so what I'm getting off of that is a rolling resistance, and I have a way to equate that to what the flat surface rolling resistance would be for that smoothness of a surface.
Yep.
Outside roads are usually pretty rough, so there's usually a kind of the rougher the surface is, if you think about it, when the surface is perfectly smooth, you get this nice smooth compression, flat compression in the contact patch.
Yep.
So the casing is only bending in limited areas. Now you add some surface roughness. Well, now that casing and material, the rubber material and the tread, all that stuff is actually kind of having to conform to all these little irregularities as it's going along. And what that ends up doing is adding even more of those losses. So there usually is like a conversion factor. It's usually somewhere between, for a typical well-maintained road, it's somewhere between 30, usually a factor of 0.35. I'll usually multiply the results by 1.35 to 1.5, somewhere in that range.
Okay.
I think my default on my I'll look at what I have here on my spreadsheet. I'm using where is the factor? I had it on here, 1.5. I'm using 1.5 in my. So basically, the result I get for a smooth surface, I multiply by 1.5, and that'll tell you what the result is for a rougher surface. Now, when you get to a certain point in the rougher, and this is getting into the impedance idea, is that assumption of the flat rolling resistance to, or the smooth roller to outside conversion, that'll hold to a certain point as you're increasing tire pressure or you're increasing speed even on a certain surface. And what we found, and I came across this, is I found that it was a test I was doing outside where I wanted to see, okay, on a roller, a smooth roller, as you continually increase tire pressure for a given load and a given speed, the rolling resistance will drop continuously. The harder you make the tire, the lower, and that's because by adding more pressure, you're making a smaller contact patch. There's less of the tire being deformed at the contact patch. You have less losses. It just keeps going. Well, does the same thing work outside? At the time, there were people saying, hey, really low pressures can be faster on certain conditions. Well, in order to have really low pressures, you need to have really wide tires. And there's all of this, that doesn't make sense because everyone's racing on really narrow tires and they pump them up as high as they'll go, and it feels fast, So I still remember the time I went out and did this. I did this testing. Is I started out with really high pressures and then just let air out as I went along, and then at the end of the test came back up to like a midpoint pressure and repeated that one just to make sure things were consistent and stuff wasn't changing in the environment. It didn't take very long to do all this. Well, on those ones, I had some tires I had them pumped up to probably almost 140 psi. I probably shouldn't have on the wheels I was running, but I knew it was a short test. I'm not going to.
Yeah.
Well, before I looked at any of and so I just go out, and the beauty of this testing is you have no idea what's faster, what's not as you're doing it. You're just going along, and I was using Robert's method for this test. I had a course I call a half pipe course, and I would go out there and I would just do these runs on it, and I'd come home and download the power file and try it and analyze it. Well, before I got home, I was thinking, God, maybe those people are wrong. It felt so fast when I had the tires pumped up super high. It just felt, I could feel it. The bike was skittish, and it felt fast, right?
Yeah.
Yeah.
And I get home and I start looking at the data, and I'm like, oh my gosh. If you look at a plot of increasing pressure, the rolling resistance dropped, and then above around 115, I think it was PSI, all of a sudden, boom, it dramatically, those last two, the higher two pressure points that I did, dramatically increased the resistance to forward motion. It took me dramatically more power to go the same speed at those pressures as the lower pressures. I'm like, that is so weird, because and so I repeated it, and sure enough, it was the same thing again. And it was that was kind of the beginning of my thought on, okay, what's doing this? And if you start thinking about up until the pressure gets to a certain point, all the suspension of the vehicle, you being a guy on a bike, is in the tires. Right.
Yeah.
And so the tire, it works as a simple spring. The damping is really, if you think of it, you guys are engineers, so you'll know this. Again, I need another picture. I need to draw my spring mass damper.
I know, right?
Right. So you got this mass, it's suspended by a spring, and it has a damper in it. Well, it's a simple, 1 degree of freedom system there for that. And in reality, there's another spring mass and damper on top of that. Right, yep. Which is the person and their contact points, the mass of the body to the contact points. There's another spring mass damper. So as long as that lower one, which is your tire, is soft enough, the majority of the energy goes into that, and the other part of the system doesn't get excited at all.
Okay.
And the interesting thing is that system has very low damping if you're using very good tires, right? Now, as you increase the pressure, you're stiffening up that spring in the bottom, the lower, below the first mass there, and you're stiffening up that spring, and so all of a sudden you're starting to put more energy into that other part of the system. Yep. Well, once you start doing that, you start actuating that damper, which is your soft stuff that's touching the bike. Yep. So your hands, your feet, your rear on the saddle. Yeah. Yep. And there's a lot of damping in those materials. And so once you stiffen up the tire so much that energy can get through, and that energy that's coming through is going to be a function of not just the road roughness, but how fast you're going. Yep. So and so I kind of coined this term. I called it the breakpoint pressure. Okay. And this was a few years back after Josh had left Zip, and he had taken up the mantle of Silka and started on that. He contacted me. He said, "Hey, we've been doing this testing. I want to show you some stuff." And I'm like, "Oh, what is it?" He goes, "Well, it turns out there was this road that was nearby us that was being resurfaced." Yeah. And so we took advantage of the fact that it was being resurfaced, and we did the same testing that you did, but we did it on these varying surface roughnesses. Yep. And guess what? We saw the exact same thing you did. I'm like, sweet. Okay, I'm not imagining this.
No, you're not making this up.
And so at that time, Josh was like, I really want to come up with a good term for what that is, because there's Jan Heine likes to call that suspension losses. And I never was a big fan of that being called suspension losses, because in reality, if you have your tire and size and pressure set up right, that's your suspension. And I can understand why he calls that, because in a lot of other vehicles, that's what that's called, is suspension losses. Yeah. but Josh seemed to like he liked the idea of calling it impedance, and I said that sounds like a great idea. Of course, I have a lot of electrical engineering friends who don't like the use of that word impedance, but it kind of works. But it's not technically an analog of what they like to call impedance, electrical impedance, but it is very similar in that it's kind of the idea that in a DC state, or like the flat surface state, if you think of that deflection of the tire as being like DC voltage, you can have a different resistance or impedance if you put an AC circuit through it now, depending on what the other parts of the circuit are. And so it's the changing of the voltage, or it's that extra energy now. So you got a rough surface, so you have changing. It's not the DC, it's not the flat surface. So it's kind of it's a somewhat apt analog.
Yes.
But that's kind of the idea, is that at a certain point if you stiffen up that suspension spring of the tire to a point that you're transferring energy through the tire, that energy can get through that instead of being just put back into the contact patch.
Yeah.
If it starts getting up into the rest of the bike and starts shaking the rider, that is just pure loss. It cannot be recovered.
That's one of the most interesting things I learned with rolling resistance, is how much the vibration in the body actually slows you down. The friction losses, the heat transfers through the body, how you get fatigued as a rider, just that alone can, if you have a smooth ride versus a bumpy ride, how much that affects you over a long ride is unbelievable.
Yeah. Yeah.
So that qualifies as the best definition or explanation of impedance that I've ever heard. So thank you. And I think anyone listening to this now fully understands impedance. So we had Josh on the show. We interviewed him last week, and he explained it. He did a great job, but I think you took it to the next nerdy level even again. So
just think how it'd be with pictures.
Oh, yeah. He's so awesome. Okay, so now that we're all rolling resistance experts, we understand what it is, thanks to you. Let's talk about how we can actually take that knowledge and apply it to our bicycles to make us faster. So I think one of the first things that people do, and there's an old diehard crew of people who still believe that tubular tires are the only way to go. So in the past, tubular tires were faster than clinchers, but as clincher tires have developed more and more, I think it's safe to say that clincher tires are fast, if not faster than tubular tires nowadays. Can you confirm that?
Yeah, I would agree with that.
Okay.
And I like to say that it's not really how you attach the tire to the rim that's really the difference between a tubular tire and a clincher tire, or even a tubeless tire. It's not how you attach it; it's what it's made out of.
Right.
That matters.
Yeah. Okay. The next big thing is, we've got a few things. First, we've got the tube debate. So you've got butyl tubes versus latex tubes. Mm-hmm. From your research and study, how much faster is a latex tube when you compare it to a butyl tube?
On typical road surfaces, a butyl tube will add somewhere between 3 to 4 watts per tire of rolling resistance. So yeah, having a pair of, there's all thicknesses of butyl tubes. There's it may be a little better with the thin-walled butyl tubes, but those tend to be kind of the worst of both worlds. And that you have, you could have a latex tube in there, or you could have a thin butyl tube. But what happens is a thin butyl tube is considerably more apt to be pinch flatted if you happen to bottom out your rim, as compared to not a thick butyl or even a latex tube, and it's slower still. So a lot of people like to say I'm not going to deal with the latex, they're so expensive and I have a hard time installing them and all this stuff. I'm going to go with the thin walled butyl, and I'm like, oh man, you just made the worst choice.
Yeah, there you go. We've talked a lot about tubeless. I see tubeless as becoming the future eventually. What do you see from a tubeless tire with sealant in it versus a tubeless tire with a latex tube? Have you done any studies on that and compared how fast tubeless can be when you remove your tube?
I actually have, and again, this is one of those things it's very important to be comparing apples to apples as far as the tire part of it goes.
Exactly.
If I take a tire that's intended to be run tubeless or is tubeless ready, in other words, they want you'd run sealant in it. If I've done tests of this because I wanted to test these tires, but I didn't want to have to go through the hassle all the time of putting in sealant, having it seal up, making sure it's sealed. I'd like to be able to swap. The tests themselves take like 10 to 15 minutes, and in between, I'd like to be able to just swap tires. Yep. So I look to see, okay, for a given tire, if it's run tubeless or I stick a latex tube inside of it, at the pressures that I've been testing at, which originally I was doing all my testing at 120 psi. Lately, I've been doing most of the testing at 100 psi. Yep. Just because tires have tended to get wider, and so have rims and all that stuff. And but at those pressures, I find that there's no difference between a particular tire with a latex tube or being run tubeless.
Oh, so
now
the resistance is equal.
It's basically equal. So any tubeless tire that I test, I'll test it with a latex tube inside of it.
Huh.
But that doesn't mean I'm going to use it that way. Although there are like I have probably the fastest tubeless tire, and it's actually one of the fastest tires period out right now is the Vittoria Corsa Speed.
Yeah,
I have that on a set of wheels, and I have latex tubes inside of them. Only
really?
because that set of wheels I don't use very often.
Yeah, and the sealant thing becomes a bit of a pain.
And
yeah.
so what happens is the sealant will dry out or all this kind of stuff. And I've been using them in that manner, and I haven't found them any less or any more susceptible to punctures or anything. Yep. Most of the flats I get, I've had flats with them, but usually it would be like a Michelin wire, which would be something that would which you'd be surprised at how latex tubes can fend that off.
Really?
Yeah, I've had staples in a tire with latex tube where the staple's gone all the way through the casing, but it didn't puncture the latex tube.
Because it's so flexible.
Wow.
Exactly. And so it's now that gets into the thing there is like a lot of people, they like to say, well, is tubeless faster or not? And well, it depends which tubeless and how are you running it.
Yeah. Well, the big thing that we've seen too is that, and this new Vittoria tire that you're talking about is sort of one of the first tubeless tires that actually isn't, in my opinion, designed like a brick. So, maybe the concept of tubeless is faster, but you have to be able to produce a tubeless tire that has low rolling resistance in order to take advantage of the tubeless concept. And I think now we're starting to see that the new GP4000, GP5000, I'm so used to saying that I keep skipping 5000, by Continental. Some of the preliminary numbers that we've seen from that look to be very promising. It's a good tire. That's good. Have you experimented with the amount of tubeless sealant that you've placed in tires when you were doing the rolling resistance testing, or did you have a set amount?
I had a set amount. I really haven't done a lot with how much more sealant or less sealant affects the. Yeah. I know that other people have done that. I kind of take a lot of that with a grain of salt, just because I know that if you think about what's happening inside, in order for that liquid to add additional rolling resistance, it means it would have to be pretty viscous.
Exactly.
Right? If you think about how easy, because what you're saying is that you have this, and especially when you're riding down the street and that tire is rotating, it's basically forming a thin layer of that liquid all through the tire. Yep. And so what you're saying is that bending that liquid in the contact patch is going to be dissipating energy.
Yeah, I know.
And I just can't see that. I can't see that as being something that you'd even be able to measure.
Exactly.
So
based on your awesome description of impedance and how that works, obviously we don't want to have our tire pressures too high. If they're too high, we kind of spike into no man's land and we're losing a lot of time. What is your best advice for selecting tire pressure to optimize CRR?
Well, that's something I said a long time ago. It's far better to err at the side of too little pressure than too high a pressure. Exactly. Because when you do reach that break point or impedance point, it is dramatic how quickly it it increases the or the resistance to forward motion.
Yep.
And so if you look at the slope of the curve, even with just a little bit, pretty, even 10 psi less, 15 psi less, it's not going to make you appreciably slower.
Right.
But what you do have to start worrying about is then, are you likely to pinch flat by hitting a sharp edge or something like that? So
Right.
that comes into the trade-off of tire size versus pressure versus what the surface roughness you're going over is. So if anything, it's better to err on the low side. What I would say is if you're trying to figure out what pressure, and I'm thinking of this more in terms of let's say a time trial or triathlon bike, where you don't want to have too wide of a tire, especially on the front wheel where it's a leading edge. You want to match your tire width to a certain percentage of what your rim width is. So you're limited there on how big of a tire can you use. Well, in that case, I think Josh has similar suggestions to this. Is like go with a pressure that you're comfortable with, and then start dropping it 5 psi at a time and try it and see how it feels from a handling standpoint. Don't concentrate on it from a comfort standpoint, because we're so ingrained. Like I talked about that test earlier that I did, where it was so rough it felt fast. Yep. That's a common thing. So it feels smooth, feels slow, but it may not be. So what I suggest is try riding until you start. It feels like you're hitting things that might have gotten close to hitting the rim, or oh gosh, this tire feels a little, until it starts affecting the handling or the durability, you can probably lower the pressure.
I always like to use the description of, like, if you go down the road and you're going 100 miles an hour in an old beat up car that's just on its last legs, you feel like you're going 200, right?
Yeah.
If you have a brand new premium suspension vehicle and you're going 100 miles an hour, you feel like you're going 40, right? I mean, it's night and day difference, and that transfers to the road on a bike as well.
Right.
It's funny, since we interviewed Josh, I did a long ride last weekend, and I dropped my PSI 20 points, and I just thought, well, whatever, let's see it, and no difference. It felt like there was no difference. And I think the term Josh used was, once your handling starts to feel squirrely, then add 5 psi back in and go from there. So that's a good point. Let's talk a little bit about tire width.
Okay.
What typically, the wider tires go, the CRR gets a little bit better. Can you talk a little bit about that? And is there a point of no return where you go too wide?
Well, there's a lot of angles to that question. As far as tire width goes, if we're talking about a timed cycling event where aerodynamics is important, then you start getting into the width. I think Josh calls it his 120% rule, where he says the maximum width of the rim should be 120% of the maximum tire width, measured width. Yep. And so if you get into there's a lot of information out there saying, well, wider tires are faster. Well, there's a caveat to that. Wider tires have lower rolling resistance measured at the same pressure. If you actually do but the thing is about wider tires, the main reason people would go to a wider tire is so that they have the capability of running lower pressures, so that they're less likely to encounter the break point pressure, increased impedance, and they're going to increase their comfort. Well, what happens is when you compensate the pressure and lower the pressure to account for the wider tire, you end up at about the same rolling resistance this is talking about tires of equivalent construction. In other words, it would be like tires in the same family, which isn't necessarily always a case of they're not necessarily equivalent over the full size range, but tires that have the same basic tread thickness, same tread material, same casing material, all that kind of stuff.
Yeah.
There are exceptions to that. I found one with the Specialized Turbo Cottons. Is they have 3 sizes now. They have a 28C. that they added to. They originally came out with a 24C and a 26C tire. So the casings were, marginally larger in size, but this is the type of construction of tire where you have a separately glued on tread, which tend to be the faster of tire constructions. That's similar to what the Vittoria Corsa Speed is as well. Well, when I tested those side by side, they didn't seem to they weren't very different. They weren't as different as I expected them to be at the same pressure. I expected the 26C to be relatively faster than it was. And I started thinking about what was going on, and I took a caliper out and I measured the tread that they had glued on to each of the casings, and it was the same tread. It was the same width tread. It was the same thing. So basically, they made two different size tires. All they changed was the width of the casing, and they glued on the same tread. And so what that showed me was the majority of the rolling resistance was in the tread and not the casing.
Yeah.
And that unless you scale everything, it's hard to have blanket statements about wider is faster, because in this case the wider wasn't necessarily faster. But what was nice about the wider tire, and I've used a lot of the 26Es, is that because it is wider, you can run it at lower pressures and not run the risk of pinch flatting. So,
okay.
Yeah.
So that's the tire. What if the actual rim is changing in widths? We've seen people go from these, 19 mil, 17, 19 mil brake track widths with a sometimes 13 mil internal hook to hook.
Yeah.
Now companies are going super wide inside, 23. I think some guys are even up at 25 internal.
Yeah.
How does that affect rolling resistance?
Well, in my view, how that affects rolling resistance is how it affects the width of the tire that's mounted on it.
Yep.
So if you take a tire that's nominally rated as a 23C and you put it on a 17 millimeter internal width rim, it's going to measure probably pretty close to the 23 millimeters across, because that's that designation of 23C is being measured in that sense, in that way. Now, if you put that same tire, which has if you think about it, if you took the tire and you unfolded it flat, it's got a fixed width to the casing. Now, you stick it on a rim that is, let's say, 21 millimeters in diameter across. Well, now what you've done is that in between the two beads, the tire, when you inflate it, still tries to make a circular shape. But now what you've done is, if you think about it, you've taken a circular shape and you've cut off the one section that's from bead to bead, but you have the same length there. And so effectively it makes it a larger tire. And so in that case, if you took a 23C on a 17 millimeter internal width rim and stuck it on a 21, I would expect it to be at least 2 millimeters wider. I would expect it to measure 25 to 26 millimeters across. Okay. Now, to me, the pressures you would run, or the rolling resistance and all that stuff, is a function of the measured width, not the number that's printed on the side of the tire.
Okay.
So that's why it's always, when you're choosing pressures and you're everything, it comes down to what it actually measures, not what it says.
We've done a lot of work on measuring tire width and height.
Yeah.
While varying the internal rim width. We started down in 13 and we moved all the way up to, I think it was 29.
Right.
Obviously 29 is much too large, but we wanted to see what would happen and how it responded. And we've done linear regression on it, and it's extremely linear from a width perspective as you move up. The height generally stays the same and fluctuates a little bit. You have a hinge point on a tire, so you got to think, if I keep stretching that out wider and wider and wider,
right,
eventually the top of that tire has to come down and be at the same height as the two sides, right?
Right.
So the question is how much can I move out before I start to
pulling it back down?
Right. And what we've shown is that most tires that are designed today to fit on bikes of, there's an old standard called the ETRTO, which is European Tire Tolerance and Rim Organization. I think, if I might have those words backwards, but there's a lot of...
it's better than what I would guess.
Yeah, there you go. What it's based on is making sure that people riding bikes and tires were safe. And so a lot of that was based on old 13 mil internals and certain things like that. But there's some new stuff that's going out. We're part of a committee right now to actually look at how can we widen it and still be safe. Right. And we're learning a lot with that.
Yeah.
So just to get back to the rim width part of it, Tom, have you seen the wider rims improving rolling resistance or making it worse in general?
Well, like I said, it improves the rolling resistance in the sense that for a given pressure, it would increase the width, right?
Yeah.
But if you then take the pressure back down to account for the actual measured width, you end up at about the same spot. Okay. I did some tests on my rollers because the original wheel that I started out with was I used an old Power Tap wheel that had a classic Mavic Open Pro, not the newer Open Pro, and that was my go-to wheel for testing on. But since then I've had other wheels that I've been using, and they vary in internal width, and some of the wheels I have now, most of them are like 20 to 21 millimeters internal width, and I was curious, and so I took that old golden tire of mine, the GP 4000, and I was like, okay, what would and I looked at the measured widths on each of them, and I kind of calculated that if I'm rolling on the old Mavic Open Pro at 120 psi, I figured that around 100 psi on the wider internal rim width, just because of the measured width difference of the tire when it's mounted on each, should be about the same. And so I went through that, and sure enough, it is. So okay, yeah. So it's wider, but yeah. But I would never want to on that wider internal width rim. I'd never want to run that thing at 120 psi.
No.
So no. I would be afraid. In fact, I had a problem early on in some of the. There were a couple tires that I couldn't test. One was a larger challenge tire that I tried to test, but because of its construction, it doesn't have a molded in bead. Because it is that kind of what they call open tubular construction, and so the bead area doesn't have that really good hook, and that rim doesn't that's another thing we could talk about is the raised rim beds for tubeless type tires. Well, that older rim doesn't have that. Well, so this thing was I believe it was a, God, I'm trying to remember. I think it measured nominally about 27 millimeters on that old Mavic Open Pro rim. And I had standardized my testing, and I was doing everything at 120 psi. And I tried to take that thing up to 120 psi on that rim, and it just blew off. I couldn't keep it on that rim. So so that just shows you how much the casing tension had increased because of the size increase at that same pressure.
Yep. Okay. Let's talk a little bit about surfaces. So we've talked about how, a smooth roller is one thing, a gravel road is another. So if you're a rider, you're going to do a race, and you have a newly paved road versus a rough chip seal road. I know St. Croix 70.3 is known to have like a really rough course. What would your recommendation be for someone who is going from, let's say, on a smooth surface to a rough surface? Is it a pressure change, tire change? What do you recommend?
Well, I always say that you pick your pressure first, and then you pick the size of tire that'll keep you from bottoming out at that pressure. So if so, you know what I mean?
Yeah, I do.
And this, as I've started getting back more into the off-road riding. I used to do a lot of mountain biking before I did time trials and things like that. As in recent years, it just like everyone else, like, hey, let's take a kind of a road bike-ish thing, put big tires on it, and go do mountain bike rides again. I've been doing that, and so I started thinking about this a lot more. Is that everyone says, what width tire should I run? I'm like, well, what pressure do you want to run? Right. So I know that for certain things I want to run, let's say, I want to keep this in context to the question you asked about the different road courses. If a road course is rough enough that you're saying, gosh, I really wish I could drop my pressure down to 70 or 80.
Yep.
That means you're going to need to run a tire that you're not going to bottom out and potentially pinch flat at 70 or 80.
Okay.
Right. And if it's a tri-leg or if it's a time trial, then you start bringing into the trade-offs of, well, okay, what does that do to my aerodynamics, and do I worry more about the rolling resistance versus the aerodynamics? Now, if it's more of an off-road type event and aerodynamics isn't as much of an issue, then it's all about what width tire do you need to run the pressures you want to run. One classic example of that is I've done there's a race or a ride called the Belgian Waffle Ride in San Diego.
Yep.
First time I did that in 2013 for the first time, which was the second year. I had friends of mine who had done it the year before when it was invite only. And that was in 2012.
Yep.
And so the next year they said, you got to come do this. It's really fun. We go off road on our road bikes. I'm like, oh, this is cool. And so the first year I did it was in 2013. And I did it on an aluminum Cervelo Soloist. I had Continental GP 4000s 23C front and back, but on the rims I was running, they measured about 25. But I knew enough that when I got there that I dropped my pressure to about 75 psi.
Okay.
So, and it wasn't that bad. And to be fair, the off-road versions of the course weren't as long nor as rough as they are currently in the later editions of it. So I wrote it that way. Well, the last time I did it, which was 2 years ago,
okay,
I decided I wasn't going to do it on a road bike anymore because I knew how much extra gravel road and all that stuff that they did. I was like, you know what? I'm going to do it on a bike that has 40C tires on it. So I just built up a Fuji Jari as my kind of gravel bike, and I was like, I want the fastest. I want a smooth tire, so that when I'm on the road, it's not slowing me down. So I don't want treads on it. But I'm going to run it at 35 psi in the rear and 30 in the front, because I know when it does go off road and it gets into the sand, it gets into the washboarded roads and stuff like that, I'm just going to be flying over that stuff, while everyone else has water bottles flying and things like that. Because I knew that it wasn't going to slow me down that much on the road, and it didn't. But it's interesting. That was only 2 years ago, and you would not believe how many people commented that you're going to run this, over 100 mile. There's like 90 miles of pavement. You're going to use those tires? I'm like, yeah, why not? And at the end, there was so many people who were going, you were smart.
So now that we're talking about gravel, my next question was a little bit about a gravel and mountain bike recommendation. So what tire did you run for gravel on that?
On that, on that course I ran, they were Compass Snoqualmie Pass tires.
Okay, and on the road, the rolling resistance on that is actually quite good, you're saying?
It is actually pretty good. At those pressures on the road, what I've figured out is it's about equivalent to the old GP 4000. Now, from
really?
From an aerodynamic standpoint, it's obviously worse. But I wasn't worried about that, because most of the road sections on, let's say, the Waffle Ride are there's usually a bunch of people, so you'll be in a pack. You'd be able to, at least in a pace line, be able to draft people.
Tuck it in. Okay. So as far as a gravel tire goes, that's probably one of the better ones out there.
Right. But a lot of people and the key with that is that if you run it at low pressure, as long as you have a lot of width, you'd be amazed at how much you can handle. It was something I had to get through in my mind, coming from the old mountain bike. Is like, if it doesn't have treads on it, it's like it's no good off road. But it's kind of interesting that my experience in the early editions of the waffle ride using basically a regular road bike off-road, and that was really a lot of the appeal. Is like, this is so cool, we're riding all this off-road stuff on our road bikes, right? But it was the experience of that and realizing, hey, just because I'm on a smooth tire doesn't mean I'm going to instantly wash out on every little pebble. As long as you have running a low enough pressure, have a decently wide tire, it's kind of amazing how much traction and control you have.
Okay.
So that tire is, basically it's a file tread tire. So there isn't a lot of, tread to it, but if you run it at low pressures, at let's say 30 PSI or even lower, as long as you, because it's tubeless, you don't have to worry so much about pinch flatting. You're worried more about denting a rim than anything. There's about the only thing you have to really worry about is kind of a loose pebbly sand over dirt kind of stuff.
Okay, so for mountain biking now, there's a group of us trying to get to Leadville this year. Actually, most of us are in. What is your recommendation for a fast rolling Leadville type mountain bike tire?
It's kind of funny if it varies. I've asked about that because I know people who've done Leadville, and I look at, you look at the guys in the front, I'm going, gosh, I almost think you could race a gravel bike on that.
I know.
But then you watch the videos of the crowds of people going like, what's it called? Power lines and all this stuff.
Powerline, yeah, and Columbine, yeah.
And the problem is you could use a gravel bike and probably a something that had, let's say, a textured file tread in the middle, something like a challenge gravel grinder or something like that. Yep. You probably could get away with that if you could pick your line. But if you look at these videos, there's so many people. If you want to get past someone, you can't pick your line. Yeah. So I look at that, I go, oh gosh, if you're stuck in that, you want basically a mountain bike. You want mountain bike tires. And
so the Maxxis Aspen would be a good option?
I'm not that familiar with that one. Okay. I'm so old school. I still run Panaracer Smoke and Dart on my mountain bikes.
Okay.
The Panaracer Smoke. They were like the classic. In fact, they brought them back and called them classic. Yeah, the front is kind of a dart tread, a directional tread, yep. And with knobs that are kind of dart shaped in the direction of travel. When you're looking at the top, and the rear is pretty basic chunk, for traction kind of stuff in the rear.
Okay. And then my last question on this, and then we're going to get into aero, is for both gravel and mountain with the pressure, you're saying kind of go until you can feel the rocks and then maybe add 2 PSI back in?
Yeah, it's about that.
Okay. All right. And that's their fastest rolling routes. Wow. That's interesting. I'm going to start experimenting with that for sure.
Well, the interesting with off-road, and I've looked at some stuff in there. There's some really good studies that were done for, I think, like the Swiss mountain bike team and things like that, is that what they found off-road was they were doing the same kind of things. They were doing timed loops around a course, and they were varying tire pressure. And what they found was that because the surface is soft, the lower you can lower the pressure, the faster you'll go. And the main difference is that because the tire has to compress the surface, unlike on pavement, the pavement, it has some give, but it's not like a dirt surface.
Yeah.
And what they found is that you're needing to float on the dirt more than it is a suspension thing. Yeah. So. Okay. Yeah.
Interesting.
Yeah.
That's really cool. All right, I have experiments to run now for myself, so that's fun. Thank you for listening to this episode. Be sure to listen to part 2 of this interview where Tom discusses aerodynamics. If you enjoyed the show, please help us by sharing our podcast and by leaving a rating or review. If you want to learn more about our company, FLO Cycling, please visit us online at flocycling.com. That's F as in Frank, LOCYCLING.com. You can also find us under FLO Cycling on Facebook and Instagram. Until next time, ride safe.